Hello, my name is Gregor von Laschewski and I will be the instructor for this particular class. The class is Big Data, Open Source Software and Projects, and I'm glad that you have chosen to take this class. I'm looking forward to work with you on this class, and I give you now a very short, brief introduction on that class. The class is offered through the School of Informatics and Computing. The course is about the introduction of software as used in many commercial activities to study big data. The backdrop of the course is about 380 software systems that are illustrated in our web link that we have posted over here. And we will be describing the software architecture represented by this collection within the terms of our high-performance computing enhanced Apache Big Data Stack. We will discuss the cloud computing architecture underlying ABDS and contrast this to HPC systems, high-performance computing systems. So this is going to be really interesting because you're not only learning about big data, but you're learning about how Apache Big Data Stack and high-performance computing systems are interacting and differentiate each other. The software architecture is depicted with its different layers on the link that I have pointed out to you, and covers the broad functionality and rationale for each layers. Then we will go through selected software systems and introduce them to you. And you will be getting a homework that you will be reviewing some of these systems and write a little paper on them. Students will explore as part of this one or more open source systems and deploy them as illustrated in class while using Cloud Mesh and Ansible. And Cloud Mesh is a software system that we actually are developing actively. So you can contribute to Cloud Mesh activities as part of our open source management. The main activity of the course will be building a significant software project and using multiple HPC ABDS systems combined with the use of code and data to showcase your project. Projects will be suggested, or students can choose their own with approval. We need to be making sure that if you propose a project, that it will be fitting our requirements. As we are not just doing showcase problems, we have excluded certain simple projects, such as, for example, word count. We assume that this is something that is just too simple. Instead, we will be going into more elaborate examples. The nice thing about the classes is that it has a very flexible structure, and we will be trying to support this structure so that you can start listening to lectures at any time once they are posted. We have on the web page a system where we add to our lectures if a lecture is released. Once the lecture is released, we encourage you to look at it. The only thing that we are posting on the lectures is also the deadlines in our calendar for the homework assignment, and they are reflected also in Canvas. So when you try to figure out what lectures you want to do, you need to go to our class website that we had on the first slide, and you need to be looking up the calendar and you look up the lectures. And we have a number of different tracks. We have a theory track, which goes into our software systems that we indicated to you previously. We have a collaboration track, because you need to be learning how to conduct open source projects. That's mainly GitHub and Zoom, and how do you interact with us. We have a systems track, because you need to use a particular set of systems, and in order to make it easy for the class, we will be limiting our systems support to Linux, so that you and the teaching assistants have a single system to be communicating about. We give you some introduction to technologies such as Ansible and Python and also Cloud Mesh. And then we have a web activity in which you were to be adding content to our web page, class web page. All of this is done via open source through the submission in GitHub. And as a follow-up, once you have done these tracks, or even when you start out, you can already start working on paper 1, 2, and 3 if you really desire. So we will be giving topics for papers that you can choose, and you will be able to do the project once you get your project proposal in and approved. There will be a midterm. This is not a final, it's not an exam, but we will be looking over your activities, and we expect that you have the papers done by the midterm. This is a strong recommendation, and we will also recommend that you have provided a project update by midterm time so that you can focus in the second half of the semester on your final project. Hence, you can do things in parallel. But you must must be aware that you can't wait with your project till the midterm. You actually need to be starting your project very, very early on. And if you were to start your project 2 weeks before the semester is ending, you will not be able to achieve your best. Prerequisites to the class are relatively light. We expect that you have an elementary knowledge in a scripting language, and our scripting language will be Python. As Python is easy to learn from what we have seen with many students, we do not think that this is a really big requirement. However, we do assume that you know a programming language beforehand before you take this class, so that you're not being surprised about learning any programming language skills. So we assume either you know a scripting language or a programming language. So you need to be having the ability to learn naturally for all of the class activities that we do. And we will be using Linux and Unix command shell, and that is relatively easy. You can install a virtual box on your machine, and you can install Ubuntu as operating system into that virtual box and use that. A basic understanding on how to install packages and programming on Linux is somewhat necessary, but if you don't know about this, we will have a lesson on this that will teach you how to do this. The class overview on the technology part will be dealing a lot with DevOps technologies. As part of this, you will be needing to work with command shells, the usage of SSH, GitHub, and you will be creating a software stack that is required to be reproducible, and that is being achieved via Ansible. We will, however, teach you something about OpenStack Heat or other frameworks, but for the project we will be using Ansible. You will be learning how to utilize keys, public and private key pairs, and you will be practically employing this because you will be accessing remote computers. You have the opportunity to use multiple clouds. This includes Chameleon Cloud, Future Systems, Jetstream, and others. You could use Amazon Web Services or Azure. However, we are not going to be paying for this, and you will be responsible for your own pay. Instead, you can use Chameleon Cloud, Future Systems, and Jetstream if you do not want to pay for them. We will not allow the use of online services that host already software stacks. This includes, for example, the use of Databricks. We require, if you were to use such systems, that there is a DevOps application that can be controlled via Ansible to integrate such systems if you were to want to do this. But it has to be done very carefully, and you may want to discuss with us once you arrive at that particular stack if it's a good idea on if this will be counting for the project. Let's go back to the class content. And you have already seen our structure. And we have the main three sections. That's called theory, systems, and collaboration. And we are using them in order to educate you in these areas. And you can do all three tracks at the same time. You don't have to wait till you have read all theory sections to get other things started. So on the theory, we have an introduction that gives you an introduction in digital data and clouds. We will be talking about real-world big data applications and also introduce you to some job trends that we currently see. We also see that it's important to understand data access patterns, and these are being introduced to you, and we are showcasing you typical data interaction scenarios. We show you some examples from science examples. We show you some additional general access patterns, and we are